Hello and welcome to you all. Welcome to this today's webinar in our series of interesting topics within the EVS, Electric Vehicle Summit. Transportation is literally on the move and it's becoming more and more electrified. My name is Jan Moberg, and here to join me I have, as usual, Christina Bu, the Secretary General of Norwegian EV Association. Christina, welcome.
Thank you, Jan, and welcome to all of you joining us today. There are many new EVs being launched this year, and one of the most exciting EV news is probably the launch of the Volkswagen ID.3. It signals a new era of volume in EV offerings.
Yes, the ID.3 launch was certainly great news for the industry and for the market and for us as consumers. More EVs are on the road than ever before, which leads us to today's topic. How will this development play out? What about the grid? And when all these cars need charging, how will this play out? And remember, please do post questions when you have them, when you hear the presenters, and we'll take them afterwards.
It is definitely an exciting topic, and here to give us an introduction of how electric vehicles and buildings help keep the power grid in balance, we have Anne Sofie Randal Risnes, team leader at Statnett. Together with the companies Tibber and Entelios, Statnett has performed practical tests which show that electric vehicles and buildings that use electric central heating boilers can offer their power to balancing the power market by responding automatically to electronic grid balancing requests. This is pretty heavy. Anyway, Anne Sofie, you're here to share your learning from this project, and we're certainly eager to learn more about your findings. I know myself that I get this question a lot from, especially from outside of Norway, that can your grid handle all these EVs? Yeah, you're welcome.
Thank you for the introduction. So I guess it's important to start with explaining why I'm here and why do the TSOs engage in flexibility. Because as you all know, the demand for flexibility is rising within Europe, but also within the Nordic system. Even though we've been spoiled for many years with hydropower, we also see that the changes that are happening because we're actually because we're actually working towards this electric future is also challenging our system. So when the fossil and nuclear production is being replaced by renewables, and when we're building new interconnector capacity to other energy markets, we also need more flexibility to balance all systems. Because as you probably might have heard if you've been to previous discussions of charging, there needs to be a perfect balance between production and consumption in the power system, every second, every minute of every day. And this is the job of the TSOs. And if we're going to solve this job, we need flexibility to maintain this balance. We already have flexibility markets to help us, and they are called balancing markets. And today I'm going to give you some insight in how we're working on introducing charging and new consumption into these developing balancing markets. So for those of you who are not familiar with the balancing market, I can assure you that there are many more of you. So this will be a typical discussion we have. We will talk about flexibility, but we will think about hydropower, because that's basically how we've developed our markets and our power system, and they're used to talking with us. They're already part of our ecosystem, our energy ecosystem. But when we are introducing and want to get in contact with the new participants, we need to change the way we talk. We suddenly understand that the old digital environment doesn't quite understand how can my flexibility translate into the need of the TSO. So when we see that we think we have a clear description of what we need, we understand through this dialogue that the need needs to be described in a more general way. So the way we see it, we've performed several tests also earlier, and flexibility from the electrical vehicles, they can be both simple and more advanced. You can start with optimizing of the charges for lowering the electricity prices for the consumers, and that's basically already happening, as I guess the next speaker will be able to tell you a lot about. But the delay and start of charging is really a good source for flexibility through our flexibility markets to ancillary services for the system operators. And there are a lot of R&D projects and there are a lot of commercial pilots ongoing all over the world to see this, because although it's technically feasible, there are some uncertainties related to the business models and market entries. And this is where the pilots and the practical test come in as an important tool to further development. So basically, this year we're doing a pilot called eFlex in Norway. We have already done some tests. We're still doing testing this fall, so the evaluation report will of course be published when we're finished. But what we do is easy really, because we need flexibility and we have these markets. And there are some entry barriers to this market, for example, the bid sizes. But we know that these bid sizes will be smaller in the future, because that's also the part of the European regulation. So we're trying to with smaller bid sizes down to 1 megawatt, we're allowing for smaller flexibility sources to take part of the market. So we're already testing the future market today with the new rules. What we're also doing is using the electronic bid ordering, so that we could also take step forwards automation of the entire value chain from our IT systems and tool for predicting balancing down to the electronic bid ordering and the value chain of the flexibility. So basically, small bid size, electronic bid ordering, simple, but it solves a lot of our issues. And of course, even though we're still having tests, we already have some graphs. And what we see here is what happens when we order a bid of 1 megawatt. And we see the response time of 55 seconds from the signal to full activation. And we called for 1 megawatt, and we got pretty close to 1 megawatt, 1040 kV delivered from 160 cars. So that's also part of it, seeing how could you, because when we order a amount, it's important to understand what does it take to activate this amount. And the ramp up can also be controlled, and how it should be controlled would be an issue for further discussion, because that's one of the true values of the new flexibility sources are their controllability. So that's something. So key learnings already. Devil is in the live testing, because even though we have the documentation, we need to test it live to see what the understanding is and where are the edge cases and the false assumptions. We're paying attention. We see we need to pay attention to the non-technical details. They can sometimes be larger than the technical and will highly affect the scalability of what we're testing. So in order to move forward, the whole value chain must be handled if we're going to realize the flexibility potential. And I think I'll come back to more on the discussion later. Thank you.
Thank you, Anne-Sophie. I have a quick question to you about the eFlex. Has anyone else done this prior to you?
I think there's a lot of testing, but I haven't seen directly this into the MFRR market with electronic bid ordering.
No, so this is sort of a greenfield for us to follow.
We like to think so.
Impressive. Well, thank you. As I said, we'll take questions when we get to our panel discussion. So please, delegates out there, post your questions, submit them in online. Moving right along, we will now hear from Tibber and their founder and CEO, Edgeir Aksnes. Edgeir will share with us how the robots can make charging cheaper. Edgeir is the founder of Tibber. It's a Norwegian company that develops solutions that allows you to change power supplier automatically, where robots buy the cheapest renewable power for you at a spot price. Now they're expanding throughout Europe. In this introduction, Edgar will share Tibor's vision about smart charging and electric vehicles at home. Screen is all yours, Edgar.
Thank you, Jan. Thank you for a good intro, and thank you for participating here. I hope you can all hear me.
All good.
All good. Excellent. So let's talk a little bit about robots. So we're not talking about robots in the classical way, but in robots in terms of software. And as Jan was telling you, Tibor is a digital energy company. So we basically have put the whole energy supplier into an app, and the app starts trading energy for you. However, the topic of this this conversation is more about using assets that you as a consumer own and have at home. And one of the key features in our offering today is the ability for you to connect your electric car, and then to get a couple of cool features around that. And just as a background, what we figured was that when owning a car, very much of the time that you actually own the car and have the car stands exactly like this. Maybe not with a cat and a man here, but it stands in your garage, basically doing very little, even when charging. So when looking at our data, and today we have, as a context here, we have tens of thousands of connected electric cars connected to Tibor across Norway, Sweden, and Germany. And what we see is that the typical time is that your car stays 14 hours at home doing nothing, and you typically get home at 5 o'clock in the afternoon. You might connect it to the car charger, your wall box, and it starts charging. But the amount of time it requires in order to charge up to the level where you want it to be, whether it's 80% or 100%, it's roughly 4 hours. So 4 out of 14 hours, the car charging does something, but the rest of the time is it's doing nothing. And this is the fact that we're exploiting in Tibor, that your car is standing still. It's there, so it's possible for you to do something about it. And the way that you connect your car to the Tibor and Tibor app is it's two different ways. So either you connect a connected car which has a Wi-Fi or 4G included in the car, connect that one directly to Tibor. The other option is to connect a wall box, so where the wall box is talking to Tibor. So it's one of the two options, and both of them are working in the same way. And the point here is to make the technology that you have already invested a lot of money and time and love into, and to quite easily add that to your digital power subscription. And how this works is that throughout the hours of a day, the energy price is moving up and down. And in the Nordic markets today, we have all customers have smart meters, and we have hourly pricing of the energy. So it makes sense for any customer who has hourly pricing and has an electric car to exploit this fact. So instead of using the very high energy cost, which is roughly around 4 to 6 every day, there is this opportunity of moving this away from the expensive hours in the afternoon over to the night. This is the typical picture, but of course this might vary from day to day. So what is happening is that our software here is connected to the car. It sends a schedule based on the optimal time every day. The only thing you need to choose is that you're choosing which time you want to leave. And once you set that, that's typically 7 o'clock in the morning, then Tibber is constantly sending schedules and does that. The result of that is that you're automatically getting a lower price, but also there is a correspondence between low price and the load, so that whenever there is a low price in the energy market, there is typically also a lower load on the grid. So both in terms of you as a consumer and the grid, both are benefiting from this fact. But there's a bigger picture here, and the bigger picture is that when the car is charging, you typically have a charging of 5 kilowatts. So I think the average of all of our connected cars is around 4.8 kilowatts. Obviously, smaller cars have quite often smaller charging, and bigger cars with bigger batteries have a higher charging power. But the case here is that you could look upon one car and it's like this. But if you look upon a couple of hundred cars, you actually get to 1 megawatt. So if 1 megawatt, or roughly a couple of hundred cars are charging at the same time, you have 1 megawatt that you can turn off and on. And as this is not one entity, it's many entities, it's quite easy to manipulate this into becoming half a megawatt. It's just basically to turn off charging of half of these cars. So the granularity of cars charging is having a huge impact on how to regulate the power grid in a much easier way. So the other advantage of that, it's extremely fast, but it's also very distributed. So it doesn't affect one single point in the electric grid. You can distribute this across the whole country, so that you get a much more even way for you to balance the whole grid. So this is a fact that we're exploiting when we talk about not just about smart charging, about exploiting the best price of the hour, but actually exploiting smart charging to assist balancing the grid as well. To say that looking at a lot of these cars together is actually looking at a huge virtual battery. So what we've been doing is basically 3 different areas. We have been working together with consumers so that they're actually buying into the first piece here, so that they're able to get a better price, and indirectly they're balancing the grid. But basically what they're earning is roughly 20% lower energy price for charging the car. So it's coming out of 0 investments on their side. They just need having a digital supplier there, and if they own the car, it's a plug and play. So it's actually more or less free money on the table for anybody to grab there. But the beauty of that is that we can combine this with these 2 other areas. One is what Statnett was talking about how to balance the grid in terms of regulating the frequency in the grid. And we've been doing that both towards Statnett in Norway and towards Svenska Kraftnät in Sweden, where we have actually been certified as a player in the operational balancing of the grid on a daily basis. However, there is also a third component, that's one in the middle here, about the local grid balance. Because even though the grid is national and you need to balance the grid so that you have a frequency of 50 hertz all the time, there's also local bottlenecks. And local bottlenecks is typically a branch of the grid where you have a net station or a trafo standing, and you might have an overload of that trafo if everybody's charging at the same time. So what we've been doing there with a DSO or a grid company in Norway is to take a look at one of those stations, and hopefully you can follow here. Usually it's the case that everybody who's interested in electric cars, they're also interested in looking into data. And this is what we are looking at here is one specific branch of the grid outside of Bergen, where we are following the blue line here, where we see that the blue line is moving up and down all the time. It's the capacity needed for that specific net station. And then it's a threshold, that's the green dotted line, and when that has been reached, then we do something about the everybody who is charging in that area. So and that is that moment here. So what happens is that when that threshold has been reached, we are turning off car charging for all cars in that specific area. And what you see is happening is that the overall transformer power is also being reduced at the same time, and the power and this net station is able to continue its operation with no blackout or no stop in its area as a result of just pausing the electric car chargers for a while. And then just a few minutes afterwards, the transformer power is back on such a level that we can turn back the power. So this is one example of how you can also utilize the let's say the power of car charging, not just on a national level and balancing the grid, but also on local levels. And it's possible to do stuff that would be, well, it would be quite impossible to see any other way of doing that, unless in this case you would have to need to invest into a new piece of hardware in the grid, which would cost several millions. So that's the case about car charging. So it's about trying to create the beautiful triangle of getting value to the consumer, which means less cost, a lower energy price, really, and then to balance the grid at the same time, and even to benefit that you can actually achieve less strain on the local grid. But I also must say that the local grids are a little bit less mature because there is no natural market for a local grid and flexibility there. So right now, working with electric cars and balancing the grid works very well on the national level. But we clearly see that there is a future of balancing the local grid as well. Okay, thank you.
Thank you, Edgar. That was very interesting, and we're just gonna move on and keep the questions till after. Now, Dr. Markus Groll, who is the Managing Director and COO of IONITY, which is a venture between the German car makers BMW, Mercedes-Benz, Ford as well, and the Volkswagen Group with Audi and Porsche as well. Markus has over 16 years of experience working for prominent actors in the automobile and e-mobility sectors, and has a lot of knowledge of the industry, its opportunities and challenges. We're very much looking forward to your presentation, Groll, and I definitely have questions for you after also.
Okay. Yeah, hello everybody. Thanks a lot for having the opportunity to discuss a little bit about IONITY and our plans. I would directly jump into the presentation and try to share it now if I find the right button. Let me just check here. This one. So let's go to the start. So can you see it now?
Not yet.
Not yet? Okay.
No.
So now it should come.
Now it's
Can
on.
you see it now?
Yes.
Yes, you're good.
Very good. Okay, then I start now. So title of the presentation and the overview of IONITY is the future of fast charging. As Christina said, I'm Markus Groll, CEO and Managing Director of IONITY, and as I only have limited time, I directly jump into the numbers. And of course, if we talk about the future of fast charging, it's the underlying question is the future of EVs in Europe. And of course, everybody has its own, let's say, assumptions, expectations here, and the numbers we are now working with are pretty conservative, actually. But what we think is that by 2030, we will see a market share of new car sales in Europe of 25% of full EVs. Of course, we know in some markets like Norway, it's already exceeded by far this number. But there are also other countries we should have in mind, like Portugal or Spain, where the numbers are pretty low still. So this would be an European average number we foresee. And that would directly lead to a fleet of full EVs of almost 18 million cars by 2030. So strong growth of more than 30% per year, which I think is in line with what we see this year and last year. And maybe, as said before, it might be even more than that. So there will be a lot of EVs coming to the roads in Europe, and therefore there's also high need for public charging in the future. We have looked at the different segments of public charging here. So the slow charging up to 22 kilowatts, the segment of fast charging between 22 and 150, and what we call high power charging above 150 kilowatts, which is a segment we are focusing on right now. And also here, of course, driven by the number of cars coming to the road, we expect a high growth, but we expect the highest growth figures in high power charging, because we think that people want to use this high power charging technology if the cars allow. And of course, there's a big advantage in the convenience, because you have not to wait for a long time to recharge your car. So we also see applications in the city context, but the main application, of course, of high power charging will be highways and maybe also countryside roads for long distance driving. And we expect a number of something like 74,000 outlets, charging stations by 2030, coming from something like 7,000 today. Why is this the case? I mean, if we look at the, let's say, obstacles in buying electric vehicles, besides the price, the main points are which customers say are the long distance capabilities. So can I use my EV for my holiday trip long distance? It takes a long time to recharge the car. In the cities, there's not enough infrastructure available, and outside of the cities, there's nothing. So it's especially in some countries, this is still the case, and that's why on these 3 points, long distance capability, charging time, and infrastructure outside of cities, these are the main, let's say, areas of activity for IONITY. That's why we are building high power charging stations along highways with 350 kilowatts. Of course, we also know or hope, or not hope, but we see, let's say, customer usage patterns already now. Of course, it's clear that a lot of customers will charge at home or at work. Most of the charging will happen there. Then we expect something like 5 to 10% charging, public charging, like in the cities on charging stations, and another 5 to 10% of charging for long distance trips on highways, motorways. But as said before, one of the big, let's say, customer hurdles or customer issues is the long distance capability. That's why also it's just 5 to 10%, but we think that it's still very important for the buying decision that this high power charging infrastructure is out there. And of course, as we all know, Tesla showed with the superchargers that this is also highly impacting the customer buying decision. So our main target now, our future for IONITY and our positioning is now that we build a network across Europe, roughly about every 120 sites along the highways, 4 to 6 charging points to have enough redundancy, maybe even more in the future, like on some sites in Norway already. And we provide 350 kilowatt charging power, which is also quite a lot looking at the current vehicles. But there will be a lot of new cars coming in the next years, so we think we are well prepared with this high power level for the future. As Christina already said, we have 4 car makers currently as shareholders. The Hyundai Group and Kia will join soon. So then we have 5 car makers as our shareholder group, who are all having, let's say, the ambition and the target to bring electric cars on the road across whole of Europe. Current situation at IONITY, we are around 60, nearly 70 people already now. We have 272 stations live with a lot of very strong site partners, like, for example, Circle K in Norway and Sweden. We are, from our understanding, the only European entity besides Tesla who is really providing chargers across all European countries. And what is quite interesting, we have already provided more than 13 gigawatt hours of energy on our chargers, which equals something like 72 million kilometers of driving, which is quite an impressive number, I think. And that has been achieved over the last 3 years, actually. For 2 years, we are now deploying chargers, and 3 years ago, IONITY was founded. So we think that was is quite an impressive growth over over the last 3 years. Yeah, situation right now, I said that already, it's quite transparent on our website, so you can see where do we stand right now. 270 stations live right now, 51 under construction. We will hopefully exceed the 300 stations in October. And then, yeah, we will see what comes out end of this year. I mean, of course, there was also some impact on our construction activities due to the Corona effect. But we are still targeting the 400 stations by, hopefully then by mid of next year somewhere, that we can provide a really pan-European network, which also would cover then Spain, Portugal, Italy, and also Poland much better than today. Yeah, we also thought a lot about usability of our chargers. So we designed and developed together with our hardware suppliers a specific charging station, which has some nice features like the halo, we call it, so the light on top of the charger. We have a quite good cable management, which also allows to have longer cable length, a new HMI, which is very good, well visible, and also in the sunlight. RFID reader with a, let's say, guidance of the usage, and occupancy detection, which we can use then to see is also the parking lot free or not on the charger. So we are also thought about this quite a lot and invested a lot in the customer convenience and the usage of the charging station. So as a summary, as the time is quite limited here, we are heading for 400 high power charging stations across Europe. High power charging is, from our understanding, key to make the long distance EV travel across Europe a reality. It's also a prerequisite for doing so. We think also that this will drive the, let's say, also mass market adoption of EVs, as high power charging will make the EV a credible choice, a credible alternative. And last but not least, our network is open to all EVs which come with the European charging standard CCS. So that's, let's say, our positioning on what we do, and I think we will, by doing this, we will also shape, let's say, the future of fast charging in Europe quite a lot. That's the overview. So thanks a lot for your time.
Thank you, Marcus.
On the questions. Yeah.
That's an impressive tempo. Let's now have Anne-Sophie and Edgeir join us for a panel discussion. First, we have to address some of the questions that has come in from the audience, and I'd just like to post one to each of you in the backward sequence. Marcus, what's your main obstacle for growth? I mean, you obviously have an impressive plan for growth. What is the main obstacle?
Yeah, that's a good question. I mean, I'm always joking with my team that we will write a book soon about rolling out high power chargers in Europe. And there are so many stories we could tell about some issues, some things we discovered during planning or construction of sites. But in a nutshell, there are two big, let's say, things which are always difficult. One is the permitting part. So to get a permit, for example, from a highway operator or a local municipality for building a charging station. Sometimes it really needs a building permit. In some countries, in some areas, this is needed, and that could take really, really long time. And the other part, which often takes really long, is the grid connection, which we get from the local grid operators. And on some sites, it's pretty easy because there's already enough grid power available on that site. And on other sites, this is really difficult because we have to draw new cables. We have to dig the ground for quite a lot. This also takes a lot of time and planning, and also the costs are pretty high there. So if we look at the, let's say, realization time of specific sites, we have, I think the best site we have had was 3 months between, let's say, selecting the site and having it live, and other sites are heading towards 2.5 years. So this is a huge variation of timing in the different countries.
2.5 years is a long time these days.
Yes.
Edgeir, a quick one for you. Frequency balancing with national grid. What kind of ancillary markets are you participating in?
Oh, that's a good question. I don't know, actually. We are just getting electricity from local energy electricity suppliers as a, let's say, normal household or a normal company. Yeah? So we have a grid connection point there, which is on the medium voltage level. And then we have a contract with a local electricity supplier, and probably this electricity supplier is then doing all this. So we are just more or less like a normal customer, like a household or a small company.
Edgar, you also mentioned this.
Yep.
Yeah.
Yeah, I think, well, today we are operating in Norwegian and Swedish markets, and on slightly different levels. There are areas where we can bid into the regulated power markets, and then there are areas where we can bid into the frequency market, so the primary reserves. So these are on different stages per market, and it's on different thresholds. And some of the key thresholds per market is about how available is it made in order to make a distributed set of flexibility coming into play. Because normally the case is that you have big industry or big production, and as Anne-Sophie from Statnett was explaining, it's about getting access to these markets is slightly different from country to country. So right now in Norway and Sweden, and we are working on the German markets as well.
Thank you. Anne-Sophie, here's a question for you. There was some reaction to your 55 seconds. That's a lot. One of the viewers says, any reason for this huge delay?
Well,
there is proven that you can reach 6 seconds in commercial projects.
Well, the thing is, I think Edgar was talking about that you have different markets with different characteristics. And last year, 2 years ago, we did a test in another quicker market. And then the idea was to get it as quick as possible. And of course, the electrical vehicle could respond to that. But it's not always about the speed. So basically, the MFRR market is another ramp, both ramping down and up again. So it's more about finding what happened in this area and how could this be translated to the physical needs of the balancing market in the future, because the 55 seconds is not according to current requirements. So that's something we will discuss further based on these tests.
Okay. Just a quick comment. You've now heard the two presentations after you. Do you have any comments to them?
Well, I think the comments is about what also Edgar was talking about the value stacking, about how when the technology is there and the grid connection is there, there's so much potential in the charging, and there's so many needs also from both the grid companies and in the ancillary market, and also on the consumer sides when it comes to lowering the electricity bill if it's a household charging. So that's something that you kind of get a strong repetition of.
So we currently have a bit more than 300,000 full electric cars on Norwegian roads, and we might have, well, in 2025, end of 2025, more than 1 million, and we're getting more and more other vehicles as well, buses, ferries, heavier vehicles as well. Do you at Statnett see this as a challenge or more as an opportunity in general?
It will be difficult to answer anything else other than both, because of course it provides a challenge, and Ionity was talking about how much of a delay they would get on getting connection to the grid, because we cannot, even though we cannot change the physical reality, there are some physical rules when it comes to transporting this energy and getting this connection. So of course it's a challenge, but it's also part of the solution, and that's, I think, what we are exploring and seeing more and more through this test, that perhaps the more conservative old way of seeing is purely a challenge, and as a grid company and as an energy industry as a whole, I think we're more able to embrace it and work together to find a solution.
So and what about you, Groll? Do you think is this the same with the power companies in Germany, or are they in general more skeptic when it comes to the electrification of transport and the grid operation?
No, well, I mean, it's I would not call it skepticism. It's just as you already said, it's just a technical process which has to happen. And the interesting part is that there also the regulated timelines for the local grid operators are very different in the countries. Yeah? So in some countries, like also Norway and Sweden, it's pretty easy to do that. Yeah? and the grid operators are quite flexible. Whereas in other countries, I'm not saying any names now, but more south or eastern countries, it takes forever to get a grid operator becoming active, as they have a long, let's say, lead time in their regulation. Yeah. So that's the main obstacle I'm seeing. And sometimes, of course, you have specific sites where the local grid situation is difficult, yeah, and there's not enough power there in this local area. And then, for example, we see that also in Spain on some sites. And there we are now starting to work with battery storage systems to overcome these, let's say, grid hurdles. You know?
And Edgar, you come from a small town, or your company is actually based in a small town on the western of Norway, and you're now entering Germany, as you're saying. Why would you succeed in Germany with your solutions?
Now that's a truth with a couple of nuances. It's the case that we have the HQ here on the western coast of Norway. We also have operations in Berlin, Stockholm, and Helsinki. So we are already quite a distributed team. The case about the German market is that we find it very interesting when it comes to the focus of let's call it the green focus in the population. I think it's actually much greater focus there compared to, for instance, our home market of Norway. So that's one thing. The other thing we are seeing is the one thing that you mentioned initially, Christina, is about the introduction of Volkswagen ID.3 and a lot of new models coming into the market. And we see the German car manufacturers as a key in terms of the transition over to electric mobility. So we were actually taking a bet on that going to play quite a big role, and we saw 2020, 2021 as the big of this huge transition, and we hope that that's going to be the case, and it looks like the case as it is right now.
And Marcus, one more question for you before we probably have more from the audience.
Yes.
But I just have one question, because you're now rolling out 350 kilowatt chargers. But your owners' cars that are currently being rolled out, apart from Porsche and Audi that can charge at 150, they're max between 50 and 125 kilowatts. Mm-hmm. So did the owners forget to speak together when planning the new charging network?
No, they have spoken, I can assure you. And the logic behind this was the quick, let's say, development cycles we are seeing now in that technology, and also the fact that there are a lot of new cars coming in the next 2 to 3 years on the market, which have technologies on board which are not communicated yet to that level. You know? So, and on the other hand, we are talking about infrastructure. So what we, of course, and also especially our shareholders wanted to avoid is that we have to replace the chargers after 3 or 4 years. So that the technology is really future-proof, and especially also the grid connections are big enough to also serve the future generation of EVs. And otherwise, it would be a huge reinvestment after 3 or 4 years to upgrade the grid connection and have new charging hardware there. But of course, I mean, on the other hand, you are also right. I mean, the mass market, a lot of EVs, like especially the ID family, will be more in the range of 120 kilowatts. You know? So we will see a mixture of cars, and therefore, I think. We will probably also adapt our hardware a little bit in the future, so also having maybe some chargers with less than 350 kilowatt on some sites. But on the other hand, of course, we will be always having 350 kilowatt also to show what is possible, because that might also motivate other car manufacturers to say, okay, let's now go one step further and have an 800 volt board technology like the Porsche Taycan has.
Very good. We have time for just 3 quick wrap-up questions. The first one to you, Anna-Sofia. As a grid operator, wouldn't it be great to have huge batteries out nearby the fast chargers? I mean, can you accommodate that?
Well, in the end, it's also about business model, and somebody needs to pay for everything that's invested, and someone needs to earn money if it's going to be a service. So I think basically, and that's also what we said, when it could be easy and it could be more expensive. For of course, if you could rely on services and get a lot of the value from changing the charging, it's a lot cheaper than the batteries. But at the same time, we're all the time watching how the prices on batteries are are changing rapidly. So we don't know what's going to be the
Optimal.
right market solutions of the future and decisions. So we just need to make the system so that the people that are doing the commercial side could deal with it.
Because a cheap end solution could be expensive for you as a grid operator, of course.
And then it is
Yes.
expensive for the consumers
Yes.
because they pay for it.
Marcus, quickly, will you offer more of a slow power charging? You're talking a lot about fast charging, but how about cheaper, slow charging?
No.
No?
It's not in our scope. We really want to focus on the high power charging segment. There are so many other companies playing in that slow charging market. It needs completely different skill sets, different hardware. So we don't think that makes sense for us right now.
Okay. Last question for today to you, Edgar. What's, in your view now, the missing link in order to optimize your robotic view and plans?
I think that's the work that is now ongoing for several of the grid operators. So it's about getting a slightly modified framework so it's easy to participate, because everything is now constructed around the fact that you have 50-year-old power stations delivering megawatts or hundreds of megawatts at the same time. So getting that to a decent level all over Europe will give access to a new load of flexibility, and that's that we see is going to be happening in the near future.
Thank you. Christina?
Thank you. Everyone, we are very soon on to the second part of this webinar with Kempower, which has some new technology when it comes to fast charging. But first, look at this.
It all started with our desire to drive the world in a better direction. We combined 70 years of experience in power electronics with our fresh ambition for making the world just the way it should be. Electric vehicles are the future, both in passenger traffic and in heavy industry. But in order to establish a better future, we need charging solutions that work right now. Solutions that hold their ground in the deepest mines, the coldest seas, and the driest deserts, so we give them the Finnish treatment. Our products can take the heat of the hottest Finnish summers and the freezing cold of our winters. We have the clever engineers to make sure you don't have to be an actual engineer to use our products. And if you survive Finland, you'll survive anything. We bring you smoothly running charging solutions in a cleaner, smarter, and brighter future. Charging solutions, built to last.
Welcome to one of our sponsors, Kempower, and Tomi Ristimäki, who is the CEO. He has more than 20 years of experience in electrification and has been in the electric vehicle business since 2011. Kempower manufactures and commercializes charging solutions and services for electric vehicles and machines operating in challenging conditions. I think, Tomi, that you will tell us more, and I know that you opened the first fast charging station with your solutions here in Norway, and we're eager to hear more about it.
Thank you. It's very interesting to be here and actually share some insights about how our views of fast charging are doing. And actually, you can expect to see more charging stations actually building in Norway this year still. So I will jump directly into the presentation so that we don't spend too much time on other things. Hope you can see that.
Yes.
We'll move forward. So Kempower. And basically, also as you see on the video, we see the electric vehicle industry as a little bit wider respect. So we are talking about where Kempower operates. We work with the off-highway equipment, so very heavily involved today with the underground mining, which is not the topic today. But also what we see in the cities of the off-highway segment, as we call it, like street sweepers are moving to electrification, all the city maintenance equipment, not to mention the commercial vehicles, logistics, trucks, garbage trucks, everything is moving, and as well as private cars. And today, these all are basically, my topic today is about hub charging. And today, of course, the market sees them as a separate hubs for the separate things. And of course, we would like to also to change that. And how we do it, we are also, you need, of course, the basics, so the technology and the solutions behind it. So modular, scalable, flexible. As we see, all our charging units are based on the same 50 kilowatt modules, and this is not seen as a single charger as traditional thinking is. So there is no power limits on system level. So it's mainly the grid connection is the limit. Or if you would like to see batteries installed, but like mentioned before, that's more like an economical question today, who pays that. But modern charging system, as Kempower sees it, is not anymore based on the idea of separate standalone chargers. And these typical ratings of 50, 150, 350 kilowatt power ratings for chargers do not actually have any real meaning. When you're charging a car, every EV driver knows that not any EV available today will actually keep the power demand the same during the charging cycle. And multi-output, it was very happy to see like Ionity presentation with multi-output as an EV driver. I hate these single spots, what we see in Finland today. And multi-output is actually the key for making the EVs, not only the power range, but providing enough points for the EVs. And looking at our charging satellites, they don't steal the space from the vehicle area. And actual charging units in our world can be moved even 80 to 100 meters from the actual charging points, so actually leaving space for the cars. And dynamic power sharing maximizes the usability. So any charging output can be any power at any time, as the actual system requires and actual vehicles are asking for. And the system is also done so that it's a future-proof from the point of you can add connections, you can add power, you can upgrade the system to actually service the higher power needs of the future without needing to make the investment immediately. So starting from the modular and scalable, typically when you talk about electric bus charging, it's considered, of course, high investments for the city. And here we have basically, thanks to the dynamic charging unit, you can basically use the same charging hardware, the actual power units, the actual charging units within the charging power units to provide power when it's needed to the bus. And normally when you're talking about public transportation, that would be priority one. So a prioritization system, whenever the bus comes, transfers the bus to the public transport thing and keeps only the, let's say, the maintenance power for the cars. But as soon as the bus moves away, you could basically share the power for the electric cars. And that way also use the same investment, the high investment to provide more use. And when we are talking about also the grid connection, there is a certain limit to the grid connection. And this way you can utilize the whole grid connection power and the hardware power all the time in different spaces. And this actually, like mentioned before, any output can be any power in any time. It's the maximizing the charging power availability and not buying idle power. So this is very many cases, especially with the HPC, high power charging stations, that when the people make the investment, if we are talking about the 350 kilowatt, 150 kilowatt, you have cars who actually charge only with 50 or 100. So in our system and in our world, how we see it, this 150 kilowatt charging output changes to 50 kilowatt whenever a smaller car comes. So it doesn't actually steal the power from the next one. So you can basically, the charge point operator, the service provider can actually resell the power as it is freed from the other vehicles. And how we see the hubs as well, especially when the logistic trucks, all the transportation, garbage trucks, everything moves forward. You can have different voltage outputs, you can have different power outputs from points. And basically, like mentioned, the future-proof when the system is designed for the upgrade, you can add any power, 50 kilowatt, 100 kilowatt, within minutes. So we are talking about upgrade times, no installation needed as soon as the output is enough, and of course a little bit more when you need to add charging satellite in the system. And during the dynamic charging service, as a good example, you could create with the minimal without needing to add more space. It's anywhere, it's a shopping mall, it's any place can become a charging hub for the multi-vehicle approach and multi-output, multi-standard. Thank you. That was.
It's very interesting, and I find it also a bit curious that why are you in Finland always this innovative? You hardly sell EVs in your country.
No, that's true. There's a lot of things and a lot of people who like to think about things, and of course our company is we have more than 50% of the employees are EV drivers. So a lot of the ideas also come from the idea to trying to create a system that serves actually us as well.
Yeah, and just to it was a bit complicated maybe, but what is really the cool thing here is that you have the charger off-site really, quite far away can be, and then each charger can deliver what the car asks for. So because a car would demand different kind of speeds, not just in general, but also during the curve can be, high at some level and then slower. So then the rest of the power will be available to other cars, right? So
yes, exactly.
So the challenge is only if you have a site with 10 Porsche Taycan, that can be a challenge, but mostly that will not be the situation.
Unfortunately, I don't have that much experience with the Porsche yet, but we do have Audi e-trons, which are the 150 kilowatts, and we do know that the power doesn't stay constant throughout the cycle. And it also solves the issue of people, let's say, keeping the cars too long on a site, and then the charging queues forming up. So it's easier to actually add more, and you can transfer the power to the next one and not to, let's say, occupy the power when the car actually doesn't need it.
I know that we have one person in the audience here following from New York, and he's in charge of putting up fast chargers in New York City, where obviously space is really a big issue. So I guess this is probably something that can be interesting for cities with a lack of space, and the fact that you can actually put them in malls, etc.
Yes, exactly. Yeah. And this is basically what we see as a biggest problem in the Finnish EV infrastructure today, is that they have a too little amount of charging points in single sites. And you can never trust when you're driving these long distances that the chargers are free. And even like you say, we have a little amount of EVs, but we do have charging queues because of this problem.
Yeah.
Yeah.
And your first station is here in Norway. It's 40 minutes outside of Oslo, at Espa, Stange. Do you see Norway as sort of your test market?
It's a good test market, and also in a way, amount of EV makes it a real EV market. And the market actually sees the need of this kind of future solution, which in many countries is still like a starting phase. And let's say the people actually handling charging, if it's retail chains or if it's CPOs, they are still not really seeing it in the same way as Norway. And there is a real need for this kind of future solution with multi-output.
I have a question from the audience as well. The question is, can ChargeEye become a virtual aggregator in the future, maybe combining even charging service operators?
Could be. We are today not actually in a CPO position. So basically, we are providing our solution to the CPOs, but of course we can help this through the ChargeEye, our own card systems, to in this.
Some of my colleagues also tested your station this summer, and we thought it was quite cool that you can actually follow the charge curve on the station, which is not that usual. So. And also you can use a QR code and follow the curve as well if you're away from the site.
Yes, exactly. These kind of things come up when you have your engineers are actually EV drivers.
Exactly. Yeah.
You see these kind of things happening. Yeah.
Yeah. I thought also maybe you can tell us a little bit more about buses and the fact that you want to construct sites that can deliver to all kinds of vehicles. You said a little bit about it in your introduction, but it would be interesting to hear more.
Yes, this is fairly interesting because also today we are actually building now quite several bus depots, these kind of hubs for buses. And these systems today we are now working with Sweden with one site with over 50 charging points in single site. Another one starts actually in February with almost 100 charging points over 100 kilowatt in a single site. And this actually, some of these are actually near the consumer areas. And this power could be used if it would be today. Of course, the market is different, different operators. But this power is actually idle in many cases. The bus depots are using during night, and EV drivers would actually use the power during the day. And this kind of simultaneous investment is already done. And these are in their site. And they are actually also stealing the grid connection in a way from the capacity. And this could be utilized in this kind of hub, multi-vehicle solution.
And what is the maximum power you can deliver to one vehicle?
It's more up to the vehicle, actually. It's never the charger. With the solution, like the next site in Norway will be 1.2 megawatts. And if there would be a vehicle, we could actually push it to the single vehicle as well. But this is more hardware question on how to deliver. In buses, we are working with higher power, of course, through the roof connections. And this is just, it is not a problem from the charger point of view. It's more the vehicle idea.
That's good to hear. And maybe you will be in more countries outside of the Nordics soon as well, I guess. I think we have to finish now. We're on a past time a little bit. So I want to thank you and looking forward to see more stations with this technology in the future.
Thank you.
Thank you. Yeah. And thank you, everyone. And our next webinar is on the 22nd of October. And then we are back to looking at the cars.